My name is Konrad Kamiński. I work for Allegro, which is the largest Polish e-commerce company. And today we're going to see how we can write asynchronous applications with Kotlin, with Coroutines, and with Spring. So let's have a look at this simple code. So the code is quite simple because you immediately can see what happens. It's a sequential code. There are just two things happening here. So we have a web method, and this web method does two things. First, it tries to validate a user so that the user has some access rights to get some data. And then it tries to get some products which are assigned to this user. And so let's imagine that these two methods that we have here, these two business methods, they go over a network to fetch some data. So for example, the isValid user accesses some external endpoint. So it has to go over a network and get the data about whether the user is valid or not. And the same thing applies to get products. Let's say that it uses a database server. So it has to issue a query and then fetch some data from that database server. So this code has some problems which are not visible right away. So in these situations where those methods go over a network, they have to block at some point, because if you want to fetch something from an external server, then you just send some request and then you wait. You essentially do nothing but wait for the response. And since those methods here are synchronous methods, they are blocking methods, then the thread which executes these methods is essentially blocked doing nothing. So if you have like a couple of these kinds of threads, that's not really a problem. But today we write applications which serve many users, like millions of users. And so if, for example, those millions of users would like to access this endpoint concurrently, then we would end up with millions of threads which would do essentially nothing and just wait for the response from the external servers. And that's not really possible with contemporary machines. So each thread consumes some resources, like memory, like CPU, and there's like a pressure on the CPU, on the OS scheduler, to actually run that many threads. So what can we do? So the obvious solution is to use some form of asynchronous programming. And we have a couple of options here. So the first one is to use callbacks. So with callbacks, you pass an additional parameter to a function, it's your callback, and it's called whenever the result is ready. But if any of you actually tried to write some programs with callbacks, like in JavaScript, for example, it's very, it's a case which occurs very often. You get this callback hell problem, where you have lots of curly braces at the end of your code. Your code looks like a tilted Christmas tree, and if you want to do more advanced things like exception handling or loops, then your code really looks very messy. So the other thing we can do is we can try to use some form of promise object. So if you think about things like completable future or all those reactive types from different reactive libraries like RxJava, Project Reactor, or reactive streams, they all are actually sort of promise objects where you have to execute some methods on those promise objects, and you have to learn all of them. And furthermore, you have to restructure your code so that it's not like this nice sequential code, but you have to write it in a far more functional way. But with Kotlin, it's now possible to use coroutines, where you can write asynchronous code with sequential code in this imperative style. So how can we do it, and does actually Spring support it out of the box? So the answer to the last question is no, it doesn't support it out of the box. And so we have to find out why it doesn't support it. And in order to do that, we have to look a little bit deeper at how coroutines work in Kotlin. And then we can try to solve these problems. So here you can see a simple function. It's got this modifier suspend, which means that it's a suspending function. So in Kotlin, we create coroutines, or we write those asynchronous applications with coroutines, which are created using suspending functions. A suspending function is a function which can suspend its execution. So by suspend, I don't mean that it will block the thread that executes this function. It's just that part of the function will be executed by some thread, then the execution will be suspended, and when the suspension resumes, then the execution of the suspending function will resume on possibly some other thread. So here we have a simple example. We have a function which just delays for a second, and later it just returns some constant value. So if we look at the code generated by the Kotlin compiler, we immediately can see what the problem is if you want to support it. So for such suspending function, the Kotlin compiler generates one additional parameter in our method, which is of the type continuation, which I called here a callback, because essentially it's a callback. We're going to see it in a moment. And now the return type of our function is any. So any in Kotlin means essentially that we can return any kind of value, any object. And this is because there's a special contract for suspending functions in Kotlin. So if a suspending function suspends its execution, then the true value of this function will be returned with the usage of this callback. And if it doesn't suspend, then it will just return the value directly. But the caller of our suspending function has to distinguish between those two cases. And this is why when the function suspends, then it actually has to return a special value, a special marker value, which is called coroutine suspended. And that will mean for the caller that our function is suspended, and that the return value will be delivered via this continuation callback. So in our case, we call a delay function. So delay is like the standard function which is available in Kotlin, and it's a suspending function. It's like a counterpart of the sleep method. But whereas sleep will block the thread for some time, delay will not block the thread, but it will suspend the execution of this coroutine for a particular time. So first we call delay. Delay, as it is a suspending function, it needs the continuation parameter. So we're going to provide one to this to delay. And one more thing, so the code that I'm showing you, it's actually not the code that is generated by the Kotlin compiler, because the one generated by the Kotlin compiler is a lot more complex. It's state machines inside, but here you can actually only see how it could be implemented in a simpler way. So we call it delay, we pass this continuation object, and then the delay function returns some value. So if the value returned by delay is not coroutine suspended, so it's not the special marker, it means the delay function will not return the value via this continuation that we pass to it. So it returns some value directly. So delay actually returns unit, so there is no reason to actually somehow handle this result value, but we have to check if it's not coroutine suspended. If it's not, we just return this 5, 6, 7, 8. But if it's suspended, then it returns this coroutine suspended marker value, and we also have to return the same value, coroutine suspended. And now the delay at some point in time, which is like a second later, will call the resume on our continuation that we passed to the delay. And when it calls the resume, we will also call resume on the callback that was passed as a parameter to our simple function. And if delay throws an exception, then it will call a second method, which is called resume with exception. And we will just rethrow the same exception by calling resume with exception on the callback that was passed to us. Yeah, so this. So, but you know, this is something, on this slide you can see something that we want to achieve. So we want to be able to use suspending functions normally as, for example, our web methods in Spring. And because of this different semantics of how suspending functions work, and because of this additional parameter and this special handling of the return value, Spring will not work with coroutines out of the box. So for example, here we have a web method in the form of suspending function. So in reality, this suspending function will have this additional parameter of the continuation type. And the return value will be, depending on whether this getProducts function suspends or not, will be either the value or this list or this constant value. So, and Spring, when it wants to invoke a web method, it looks at the parameters of the web method and tries to provide some values for these parameters. So for example, here we have a parameter which is annotated with path variable. So there's a handler in Spring which handles these kinds of parameters. And the handler looks at the annotation. There is a path variable, so it takes care of this parameter. And in fact, there's like a list of handlers which handle different things, like different types or different annotations. But there is no such handler for the continuation parameter, because obviously Spring doesn't know anything about coroutines. So we have to provide one ourselves. And this is the handler that you would have to write to actually force Spring to handle this parameter. So the handler must be of type handler method argument resolver. So that's the type which is defined in the Spring framework. And what it does is we first have to signal to Spring that to indicate that our handler will actually support this continuation parameter. So if a web method is a suspending function and the parameter that Spring wants to get an instance of is of type continuation, then we indicate that, okay, we can actually support it, we can handle it. And then we have to provide an instance of this continuation. So we'll provide one. But you know, Spring already has support for asynchronous web methods. You can actually do it in several different ways. And one of them is that if your web method returns a deferred result, so this is the type from the Spring framework. If it returns a deferred result, so it's an indication to Spring that it's an asynchronous web method, and the true value will be returned via this deferred result. So deferred result it kind of resembles continuation, so it also has these two methods. They are named differently. So in continuation we have resume, in deferred result we have set result, and for exceptions we have resume with exception or set error result. So what we'll do is we'll create a continuation, and it will contain a deferred result inside, so that when someone calls resume on the continuation, we will just proxy that call to the deferred result, and we are actually going to return a deferred result later on. So we're just going to store this deferred result so that later on we will try to retrieve it. So just like for parameters of web methods, we also have handlers for return values. And so in order to actually handle this case where our suspending function suspends, when it returns the coroutine suspended value, we have to provide such a handler. So it has to be of type async handler method return value handler. So first we have to indicate that our web method is actually an asynchronous method. So we check the value of the return object. If it's this special marker value, we say, okay, it's an asynchronous method. Then you have to indicate that you actually support this method by checking if it's a suspending function. And then we have to provide we actually have to handle the return value. So what we'll do is we're going to retrieve the deferred result that we remembered in the previous handler, and then we'll delegate the the handling to the deferred result handler, the default one from the Spring framework. And so by combining those two handlers, the one for the parameter and the one for the return type, we now have a solution for this problem where we now can have suspending functions as web methods. And I'm showing you this because there's like many different mechanisms in Spring exist where you have to do it in order to support suspending functions. And you actually don't have to write this kind of code yourself. So there is this spring-kotlin-coroutine library. It's available on GitHub, which actually supports suspending functions in many different areas. So we're going to actually see how it works and how we can use it. It's not an official part of the Spring framework. But what we are going to do now is we're going to take this example from the beginning where we had this endpoint with two business methods which accesses some external servers, and we're going to convert it to the one which uses coroutines, which will be an asynchronous application. It will use actually non-blocking I/O, so we will have a scalable application, and it will be written in a nice sequential way. So let's try to do that. Oh no, don't tell me that. Okay, let's try to do this one maybe. Okay, accept. Sorry for that. I mean, I don't have VPN. Right. Okay. Oh, it's not presentation mode. Can you see it? Right. So first, we're going just to create like a simple endpoint. We just use a suspending function with this spring-kotlin-coroutine library. So in order to actually use coroutines, we have to add the enable coroutine annotation on our configuration. And then we're going to create the controller. We'll just name it simple controller. Simple, let's make it suspend. Let's make it return an int. And we're actually going to add some logging statements so that we can observe what threads are being used to execute those functions. So for now, let's do it like this, and let's try to execute it. Okay, so our application is started, and let's try to call for the endpoint. Right, so we got the result, and there is some logging output. Now, our function now, that it's a suspending function, but it doesn't actually suspend. So we can use this delay function that was shown before, and let's add some logging statements after delay. So here you can see the special marker. Oh, sorry. And idea is this nice IDE which will tell you where your suspending function actually can suspend its execution by just showing you this marker. So let's try to see what happens now. So our function should be suspended for like 1 millisecond, and later just print something in the log output. So yep, let's go for it. Yeah, so we got both things in our output, but you can see that actually the second logging statement, the second statement that was logged was actually executed in a different thread. And this is something we actually should have expected, because when our suspending function started to be executed, it was executed using a thread from a thread pool, which is a part of the web container. Now, since delay suspended the execution, this thread no longer needed to do anything, and the delay function, once it resumed the execution of this simple suspending function, it resumed it on the different thread. So it's like this default executor, this thread that the name ends with, default executor is actually the one which is used by the delay function. So let's try to go to our example from the beginning of our presentation. So let's demo. So okay, so we have our getProducts function, and so let's make it suspending, and let's add some logging statements as well here, so that we can observe, what happens in which threads. But now we have a suspending function, but it doesn't suspend here, so we have to change our isValid function to also be a suspending function. So we're gonna modify it to be a suspending, but still it doesn't really give us much, because this function will not suspend at all. There is no marker here. And so what we can do is, there's like this architecture of applications where different functionalities use different thread pools, like separate thread pools, so that even if the threads inside those thread pools are blocked, because, for example, they use blocking I/O, we can actually scale the number of threads in those different thread pools, so that we will not end up with millions of threads being blocked, but only like a couple of them. And the request flows from one thread pool to the other, so that the resources are much better handled. So with coroutines, what we can do is, there is a concept of coroutine context, and that coroutine context can actually play several roles. And one of them is that it can be a coroutine dispatcher, which actually decides what threads are used to execute a coroutine. So what we can do is we can actually use the with_context function, which takes a coroutine context as a parameter. So we'll use common pool here. A common pool is something like a fork join pool. So it's like a default one. And now we can see that there is a marker here. So our suspending function will suspend the execution, and the execution of this getForObject will actually happen in this context. So it will happen in this common pool. So let's try to add some statements here as well. Okay. It's after. We have to actually run this main method. Okay, and the endpoint that we're going to access is users/user ID. I will use Konrad as user ID because there's like a database already started, which has some products assigned to Konrad. So we're going to call for this endpoint. It's users Konrad products. Oh no. Products. Okay, so we forgot actually to add enable coroutines here. Right. Okay, so now we're going to have like a little more things in our log output, and you can see what threads are used. So let's try it once again. Okay, so we got the response, and now we can see that. Okay, so the first it started in the web container, and then the common pool was used to actually execute this isValid method here. So this is something that we wanted. But so if we had to write this with context for every method that we wanted to be used, to be executed in some coroutine context, it would be quite inconvenient. So this is why you can actually use a different method to specify this context. So there is this coroutine annotation that we can use where we can specify the coroutine context that we can use. And But we want to actually have a separate thread pool here, so that all those accesses to an external endpoint, they actually happen in a dedicated thread pool, and we can actually tweak the numbers of threads which may be blocked, waiting for the response from that server. So we're going to create our own coroutine context. So let's name it external service context. And so we have to create a bean which has the same name as the one that we specified in this coroutine annotation. And this should create this context. And this is actually quite simple, because the Kotlin standard library provides a number of functions which allow you to create such contexts quite easily. So we'll create a context which has this thread pool with a fixed number of threads, and those threads will be named external 1, external 2, etc. So, and now we don't have to use this anymore. I'm gonna just add return here. And now we should have our isValid method executed in this special dedicated thread pool. Right, so let's try to call for the endpoint. Okay, we have external 1. So we see that our isValid method is now executed in this special dedicated thread pool. And we can actually put this annotation on a class, so that all of the suspending functions for that component will use this special context. We can actually define our own like a meta annotation. Let's call it external service, and put it on the class, so that now whenever we have like a different component which accesses an external endpoint and we want to share the same thread pool, then all we have to do is use this annotation instead of the component annotation. So let's try to see if it works. Yeah, so it still works. It still uses external 1. So we can actually do the same thing for Mongo. So for Mongo, we use here the product service. So we'll make this function suspending function, and let's just quickly do the same things as before. So it's before find user, and here we'll add let me just define a dedicated context. Let's call it Mongo. So it's Mongo. Right. So now we should have like a separate thread pool which will handle those requests to the Mongo database. So let's try to run it again. Okay, and you can see that the isValid happens inside the external thread pool, and Mongo happens in the Mongo thread pool. So we now have this application that you wanted, separate thread pools. The request goes from one to the other, and we can actually write applications like that, and we kind of have no other way to do it if we use blocking I/O, because with blocking I/O we actually have to block at some point. So we will end up with threads which are blocked. But Spring V, it actually introduces a new set of APIs which uses these reactive types, which uses Project Reactor, and the implementation actually uses non-blocking I/O. So it would be quite convenient to be able to actually use that implementation with coroutines, so that we can write applications with coroutines, the asynchronous applications, but which would use non-blocking I/O, so that we would just get rid of this blocking. And we can actually do it with the spring-kotlin-coroutine library. So the architecture that we have now, we can actually use it in the applications which are created using Spring 4 because there is no non-blocking I/O used there. But if you are on Spring 5, then it's better to actually use non-blocking I/O. So we have 3 areas where we have to introduce this this non-blocking I/O support. So we have web layer, we have this component which accesses an external endpoint, which right now which uses REST template, and we have also the Mongo database. So let's try to change them one after the other. So first, let's go to the web layer. Actually, it's quite simple because all we have to do is we have to change the dependency. So far we've used web MVC, and what we'll do is we'll actually use webflux. So just by changing the dependencies here and restarting our application, we'll now use the coroutine implementation, which is webflux. So essentially, we'll be using non-blocking I/O under the hood. So there's actually no change in the code itself, just the dependencies. What we can see here is that the Netty server was started, and Netty server is the one that is the default one when you use webflux. You can use other servers if you want, like JBoss, like Undertow or Jetty or Tomcat, but Netty is the default one. It's quite fast. So just by changing the dependency, we now have in the web layer we have this non-blocking I/O used. So we're gonna now try to change the thing with the user validation, which accesses an external endpoint. So if we wanted to do it with Spring 5, there is like a counterpart of REST template, which is called web client. And with web client, it's also quite easy to access an external endpoint. So we'll just rewrite this code so that it uses web client. So let's retrieve. And so web client, actually, it works on the reactive types. And this is why you have these functions like body to mono. And what we'll get here, let's go to result, is the mono of string. So a mono is like this reactive type, which it's like a stream of 0 or 1 values. So you can get a value or no value. But we actually want to have suspending function here because we use coroutines. So there are these extension functions defined on the reactive types available. So extension functions in Kotlin, they allow you to, it's a mechanism that allows you to add functions on existing types. And we can actually use it here. So we can, since it's body to mono, so we can call await first or null, which will wait for the mono to deliver some result or to signal that there will be no value. And then, since it can be null, we have to make a safe call. We convert it to Boolean because our isValid function returns a Boolean. And if it's a null value, we'll just return false. So you can see here the special marker. So it means that the await first or null is actually a function which is a suspending function. It will suspend the execution of isValid until this mono returns some value or until it completes. But this is kind of ugly because we want to use coroutines, and now we have to use reactive types and convert it to and use those extension functions. It's a bit clumsy. So this is why in the spring-kotlin-coroutine library there is the coroutine web client class. It's very similar to web client. So if you know web client, you will be able to easily use this coroutine web client. There is obviously no body to mono because there is no mono. There is just body. This is how it would work with coroutines, with coroutine web client. So we're just going to remove the old code and leave this logging statement and return a result. Now we can get rid of actually this special coroutine context because we will use the one which is supported by the web client implementation. So now we should have the isValid method. Our isValid method should now use non-blocking I/O with the usage of this coroutine web client. So let's see if it actually uses it. So let's curl for it. Right. So what we actually can see here is that our isValid method no longer uses this external thread pool that we created. It uses reactor threads from the project reactor, and this is because web client, which is used underneath, actually uses reactor threads. So now we have non-blocking I/O in our web layer, and in this component which accesses an external endpoint, both are using non-blocking I/O. So now let's go to Mongo database. So with Mongo database, we actually get the data from Mongo using repositories. So it's Mongo repository. It's this mechanism from the Spring Data project. And in Spring 5, or essentially in in the newest version of Spring Data, you can use reactive Mongo repositories, in which you can have functions which return those reactive types. So but in the spring-kotlin-coroutine library, you actually have coroutine Mongo repository. We have to define a dependency here. Okay. And in this kind of repository, our functions can be suspending functions. What's that? Okay. And we also have to enable support for those kind of repositories. So we're going to use enable coroutine Mongo repositories. And one more thing which we have to change is, so I mentioned that at the start of the application, the database is filled in with some sample data. And it happens during the handling of the application ready event, which is sent when the application is started in Spring. So now we have our insert function in our repository is a suspending function. So we can only call the suspending function from other suspending function. So we have to change our event listener to be a suspending function. And it also shows you one more feature of this library. So with Spring, you can send events to this event bus, and you can write your own handlers. You use application event publisher to publish events, and you can have event handlers like these where you specify that you want to handle some events. And with spring-kotlin-coroutine library, you can actually have listeners which are suspending functions, but you can also use a coroutine application event publisher to publish events using suspending functions so that you can have the asynchronicity all the way, end to end. But here we're going to use it only on the receiving side. So that's, I think, about everything we have to change to use Mono with Mongo database with coroutines with non-blocking I/O. So let's try to curl. Yeah, so it worked. So we forgot to remove the coroutine context. Oh, this one. Sorry. Let's try to see if it works. Okay. Okay, so what we see here is like this isValid still uses the threads from the project reactor. Now the get product list actually starts also in this project reactor thread, but it ends, so this statement is actually printed in the, there is an N missing here, so it should be NIO event loop group. So this is a thread from the thread pool which is used by Netty, and Netty is actually something, is this IO library which is used by the Mongo asynchronous driver. So essentially this shows us that we are using the Mongo asynchronous driver. So now we have our application which uses non-blocking I/O, it's asynchronous, but you still write the code in a sequential way. One more feature which I want to show you just quickly is that, for example, you can also have a cacheable. The spring-kotlin-coroutine library also supports the cacheable annotation, and normally it wouldn't support it because caching in like declarative caching in Spring works like this. So there is it's like a key value store where the key is the parameters for the methods. And here with suspending functions, we have this additional parameter of the continuation type, and it's different every time we call this method. So normally caching would not work with suspending functions, but with this library it works. So we can write add support for caching here, and we have to enable caching. I'm going to actually add some more logging statements so that we can observe different calls. We're gonna actually access the endpoint twice and see if during the second time the cache is actually used. Right. So let's once more. Okay. So we have our logging statements here, and yeah, so we can see that the first time we called our endpoint, the isValid function was called, and the next time it wasn't. So our caching works as expected. So right. So now we actually moved from having an application which used like blocking I/O to the one which uses non-blocking I/O, and it's asynchronous, and we haven't actually changed the code much. So we added this suspend modifier. We had to change from the regular Mongo repository to coroutine Mongo repository, and to change REST template to a client, but the changes weren't that big. And this is something that I wanted to show you during this presentation. If you already have a project which uses regular code, and you want to make it, you want to make an asynchronous application which wouldn't have this scalability problem, then you can actually do it gradually. You can do it only on a web layer level, or you can do it on the database level. You can do it with Spring 4 if you have an application which uses Spring 4, and then just move to Spring 5 just by changing some dependencies. And you don't have to write your code in this functional way, which is actually required if you want to create applications, asynchronous applications, with other techniques like reactive libraries. So there's a couple of things which I haven't shown you, which this library also supports. So I haven't mentioned all about those coroutine contexts, because we created coroutine context on our own, but actually, if you have a Spring component which is like a scheduler for RxJava or executor from the JDK, then you can actually specify it in this coroutine annotation, and they will be automatically converted into the coroutine context. So we have this event listener and coroutine event publisher, which allows you to publish and receive events asynchronously. There is support for the scheduled annotation, which allows you to have a suspending function which is invoked in some specific point in time or at some fixed rate. And there is also a thing called functional style route definitions. So it's actually something which allows you to specify your web endpoints in more functional way, and suspending functions are actually supported there also. So if you want to know more, you can have a look at this GitHub repository. There's a source code there. There's some documentation with which you can just by reading it, I think you can just start using it. So just go and take a look at this. So that's all from me for today. So if there are any questions, then I'll be happy to answer them. Okay, there is one there.
Is it possible to do it as well with SQL databases?
No. So the question was about the SQL databases. So yesterday there was a talk about a talk made by Mark Paluch from Pivotal about reactive libraries and data access. And he mentioned that SQL databases are not supported, at least not yet. There is some ongoing work. So if that works, that work ends up with something, if there is support in the project Reactor, or essentially in Spring framework for SQL databases with reactive libraries, then obviously it will work with Coroutines, because Coroutines, under the hood, they actually use this support from the Spring framework and from these reactive libraries. But so far, there's no support for SQL databases, so you can't use it as, you can't access it with non-blocking I/O. You can use it with blocking I/O, just like you can do it with Spring. So, for example, you can have this separate thread pool where your threads will access these SQL databases, but you will have blocking I/O. So we will have a situation where your threads are blocked, waiting for some result from a database. Yeah.
So frameworks that rely on the thread local, like Spring Security, JPA, transactions.
Yeah. So JPA. Yeah. So the question was about thread local and functionalities which rely on thread local. So with coroutines, the execution of a suspending function can actually happen on multiple threads. So it can start on one thread and on a different thread, like we actually saw. So thread locals will not work. So therefore, things like transactions will not work either. So this is like the same thing like in reactive libraries. So there is this coroutine context. It's not only used for dispatching or for specifying what thread is used to execute a coroutine. You can actually use it as a sort of thread local where you can store some things. It's like a sort of like a hash map. And this is always available from the coroutine, so you can read from this hash map. So things like security context can be actually handled this way. But for transactions, there is no support. Well, not yet, actually. Right, okay, one more.
Is it possible to have relevant stack traces, like in a regular imperative code?
Right, so the question was about stack traces. So since these things execute on different threads, the stack trace that you have is always from the thread that executes the part of the suspending function in which you are right now. So it's a situation very similar to the one that you have with reactive libraries. So essentially, you won't have this very nice stack trace as you have with sequential code which doesn't suspend, unfortunately. Okay, any other question? Okay, so thank you very much.